Hello everyone, this video has my solutions to the most interesting problems from the AlgoRun app. The goal is to control a robot to get all the lights, those lights here, and get to the end. While you walk you can go through portals, like this one goes here, this one goes here. You put your commands here. There are two functions, and the commands are either moving or function call. And then we need to find a pattern, and the function can call itself, making it a recursive and an infinite loop. We need to find the pattern that we can get everything and get to the end in the limited space we have here. So for this one, the idea is to do this pattern here, like this. And then we use it again, we go through the portal, and it applies again here. So in the F2, and it always starts from the F1. So the F2 we do front, 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 right. And when you call it, you can see that we can already use it twice. Now we need front, right. Now we can use it again, F2. So the idea is always to find a pattern that you can use many times. This is how you can fit. And now, even though we don't need to turn right, we use it again to be able to fit in the limited space. And now we need to turn left to cancel it and call F1. So this is the recursive call that will make everything loop infinitely, but we only need 3 times. This is the first loop, this is the second loop, or recursive call of F1, and at the very end is the third call. Nice. So now the next one I selected is conditionals 12. So here, once you go forward on F1, yes, then we get to the, also if you walk outside you fall. So in the pink we need to turn left, but the difficulty is how do we turn back? Because this is conditional now, that we only do it on that floor. So this is how we can turn left, but the question is how do we make him, the robot, turn back without falling there, because we can't be conditional on the normal floor, only on the pink floor. So the idea is that we need to always be turning back. So we start with this, and then on the pink floor conditionally we turn right, so we can go there, get the lights, and then we go forward to get out of it. And then that's the pattern that we will do here, that will make him turn back inside each of them. So there, and then F1 is the recursive call that will make everything repeat. And it seems to work. Nice. Now next one is conditionals 13. And here, so the natural thing is we need to go 3 steps forward, right? So we put this in F2 and then call it, and then we need to turn right. So 3 steps forward, turn right, and that's what we want to do recursively. F1. The problem is he will also turn right in the middle there. So now we need a way to not turn right there, and the only condition we have is the green floor. So what can we do at the green floor to avoid turning right in the middle is we can do another F2 here, and now it will do 6 steps instead of 3 when he's in the green, and he still turn right here. And we do it after turning right, because we need to turn right first, and then he has to go around to get all the lights, and then go around again. Nice. Next one is conditionals 14. Here, interesting ones next to each other here. So here we start going forward. Yes. Now in the blue, we want to turn left. Whoops. Blue, we turn left, and the question is, how do we make the double left turn there? So the way we do this is we call a function that will go forward twice, because we will call it here, call it here, call it here, call it here, yes. From here, go forward twice, and if it's blue, then we need to turn back. So we use the F3 for this. If it's blue, the F3, and then the F3 turn twice to turn back. And otherwise, it doesn't turn back. Only in that case that there is a blue, a step and blue, and then there, in the pink, we need to turn right. So before the recursive call, and now it should work. Nice. Next one is 15, and this is the one I think is the hardest of all. Harder than the very tricky. So if we start here, right, we can do front, 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 right. This is the pattern, so we put this on F2. Front, right, and then F1, F2. So this would be the basic pattern. Whoops, F2, F1. So this is turning right, then it will stay there because we are turning right all the time. So we can turn right only when we are on a pink floor. So now it will not turn in the middle, turns here, then it will fall here before getting the last two lights. So now how can we avoid this infinite loop? We can call F1 only when we are in a pink. So this way it will not be infinite anymore. It will be bounded. And then we have a choice there, right? What we do in the middle. One thing we can do, we have to do something, right? We can do like a left turn here and then call F1 again unconditionally. For example. And then the left turn also applied there, but it still falls here. And if we do this, change this back to be unconditional, to C, then it will actually go straight. Here also, here also. So it didn't work. So the problem is we still have an infinite loop. So if we go back to the pink left turn, then the idea, still have the idea to call it again only when it's pink. But let's have it there. Let's have the call here. And then now we need the left turn here. So this is a different order. And then we can choose what to do. We can do another F2 to make the robot walk more. It's still falling, and then the last is we add an extra turn, and now this will break the symmetry to prevent the robot from falling. And it's just the right number of calls that it works out. This is the hardest one, I think. Now conditional 17 is also interesting. So start going forward, right? At the pink we need to turn back. Whoops, pink. Right, at the green we need to turn left. The turning is always relative to the robot. Then the problem is how we avoid turning left there. We also go forward. And this one actually ends up being shorter than the space, the available space. Nice. Now let's move on to the tricky 2. Here the pattern looks simple, right? You just need to go around, but the problem is start facing the water. So you need to turn right. This is what we need to do. Yes, turn right and turn right. And now, to be able to call it again, we need to turn left to end up in the same place, so that the recursive call will actually work. Nice. Now tricky 4. Start going forward with recursion to see what happens. Now in the pink we need to turn left. Now the blue is the difficult part, right? So let's call the other function. So what we need to do? We need to turn left. And then here we pull right, forward, left, left, forward. And then this is the thing we can reuse. To grab both sides. So let's see like this first. So we need another of them to grab the other side. Because after this it goes back to just going forward, right? That's why it's falling. And then we need to go back out of it. Now with the same portal from the other direction, gets to the end. Nice. Now tricky 6. Start going forward. On the blue, we turn right. Problem is next blue, we need to turn left. So to know where we are, we can use the function. So we can turn right and call F2. And F2, we will also go forward. But on the blue, it will turn left. But the next blue, we need to turn right again. So we need to go back to F1. So now the blues alternate. One turns left, next one turns right. And then we get to the end. Nice. Tricky 7. Now it's getting very difficult. So for this, like we need front, right front here, and we need front, left front, and this is what we alternate. So this gets us to the end, but we didn't get all the lights. So we need to do something different on the colors. Now the first color is here, and we want to switch to the other side to do front, left front, to go there. But for the next one, the other direction, we need to do the opposite. For the other pink, we need to turn right instead of turning left. So this one, for those we turn right. Now we'll go back to alternating. For those we turn left. For this we turn right. Nice. Tricky 10. So we start here turning right on the pink, left on the pink, first forward, and the same for green. But the question is like if I put the green here, do not apply because it's there. So we need the green here because of the parity of the steps. Now this also works in the end. Now the last ones, very tricky. I think we will do all of them. So very tricky one. Forward, front, F2, forward, F1. So start like this. Need to turn left. On the pink. Now it's falling there, so we need to do something different. So the problem is that on the way back, it's the opposite direction. Yes, it goes too forward. The too forward has to switch from one side to the other. So in the end, we need to add another pink here that is disabled. That doesn't do anything because it's applying here, but on the way back, this will be the one that turns us left going back, and the other one will be disabled. And then on the blue, we swap it. Like it ends, we are here, and then we go back to the beginning of F1, and now it will end up reversed because it will switch the left one that actually applies according to the floor. Now for the chew, very tricky chew. Start with front right, F2, F1. So this is just alternating, yes. Now when it's green, so by alternating the functions, we keep track which direction we are going. So here, if we get to green here, if we get to green here, we do the opposite. And now for the pink, we need a turn. To avoid falling there and to continue the pattern. And when we get through from the other side, we also need a turn. Nice. Now very tricky tree. Forward. Start going forward. It's similar to the other one we did. Blue needs to turn left. But now for that blue, we need to turn around. So we need to call the function, go forward, 2 steps, and if it's blue, call the other function that will turn around. And here it doesn't apply because there is no blue after 2 steps. Now this will get us there again, the 2 steps apply. Now when we get to the pink, we need to turn out of it. And only after getting the blue. On the way back from the blue, nice. Very tricky 4. Almost there. This start going forward. Green, turn right. Blue, turn right twice. Now the green needs to turn left. So to keep track of this, we go to F2 on blue. Now the green will turn left. And we stay there in F2. Again, the blue we need to turn around. Need to turn around. So now we're turning around from the blue.
Papi, nog een ninja.
Now the green needs to turn right again, so in the blue we need to go back to F1. And now the last part is to do something with the pink. So here, the pink we call F3, and then we need to go right, front, left, to move to the next part of the stage and eventually to the end of it. Nice. Now only 2 left to go. Very tricky 5. So the idea is go forward, right? Then on the pink go right. Go forward again. The problem is, how do we turn right in the end? There is no color to switch on. So we need to use a separate function. If we do the same logic here, then it will make no difference, right? So the idea is that we call it again only when it's green. This way we don't have an infinite loop. And then after it's finished, we can use the last step. We will only run at the end of the function. So this is how we go forward for the same number of times, the 7 times that it called itself. On the return, it will move forward again. And then we are just missing to turn right and go forward at the end. Nice. Now the last one, very tricky 6, is similar, but with 2 layers of it. So we can start here going forward, then we can't go right every time because it will turn again. So we need to use another function to go forward the second time. And then we need the F1 to stop. Right, so we make it only green. Now we got to the end. We also need the F2 to stop. And then again, we have the return. After the return of F2, we can do something. So this is where we can turn. And if we turn right, it ends up in the opposite, so we have to turn left. So the same number of calls of F2. Now when we turn left, we end up facing the correct direction, and now we need to move forward again. For this we can reuse the F1 loop we already have, and make it unconditional. So now the return will turn 7 times, and then we go back to F1. Alright, that's all.